Today, we're going to continue section 4.4. In our previous lesson in section 4.4, we talked about how to go from the equation of a sine or cosine function and generate the graph for that sine or cosine function. Today, we're going to do the opposite direction. We're going to start with a graph of a sine or cosine function and generate an equation for that sine or cosine function. So the equation that we're going to write, we know that every sine function can be written as a transformation of the parent function. So we can just write it in this form. So what I'm going to need to do is to generate or figure out the values for A, B, H, and K. Well, I remember from the previous lesson a little bit about what those things do and how they affect the graph. So if I look at my first example here, the blue graph is just the graph of sine X, and I've included that just to give us a frame of reference so we can kind of see what's going on. And the the purple graph is the transformation, and this point right here is a typo, and that right there is a typo. I didn't mean for that to show up, but we're already started, so we're just going to ignore them. So the idea, if you remember, if I look at the amplitude, that is going to give us the magnitude of that A coefficient. So if I look at the amplitude, so this is the point something, comma 3, and down here is the point something, comma, negative 3. So the mean line for this function is going to be just the x-axis, because it's going to divide the graph so there's an equal amount of the graph above and an equal amount of the graph below. Now to determine the amplitude, that's just the distance from a maximum or minimum to the mean line. In this case, that distance is 3. So we know that the absolute value of A is 3. Now, it doesn't matter really whether we pick the value for A then to be positive 3 or negative 3. We can do the problem either way, but we can make our life easier if we're a little bit clever and intelligent about how we're picking whether we're going to have positive 3 or negative 3. So my observation that I'm going to make is if I look at the graph of the parent function, I start off with an up with a crest, and in this one I start off with a crest. So that's going to indicate to me that I'm going to pick the positive value for A rather than the negative one. If I started off the purple graph, it started with a trough, like going to a minimum, I would have picked the negative value. But again, you can do the problem either way. It doesn't really matter if you pick the A to be positive or negative. We can get the correct answer by picking a different value of H later on. Next thing I want to do is I want to look at the period for this function, because I remember that the period is related to the B, because the period is 2 pi over B. So if I erase this stuff out of here, if I look at my purple graph here, if I start here, I've gone a crest, and then a trough, and then I'm back to the beginning here. So this distance, if I look, I kind of wrote over it there, but we've gone from 0 to 4 pi. So I started off at 0 at the x-axis, ended up with 4 pi on the x-axis, so that distance, the length of my non-repeating function is 4 pi. So now, if I treat this like a proportion, I can cross multiply, and I have 4 pi times b is equal to 2 pi. If I divide both sides by 4 pi, I get that b is 1/2. Again, because the pi's cancel, and then 2 over 4 is just 1/2. Okay with that idea? Good. The next thing I want to do is figure out my k value. So we remember that the mean line is always of the form y equals k. So here we said our mean line was y equals 0. That tells me the k value is 0. And the last problem here, or the last piece, is to figure out my h now. So to do this, what I'm going to do is I'm going to look at my function, and I'm going to identify a point on the mean line where the purple graph intersects it. So I have a couple of choices. I have this one, this one, this one, this one, this one. Right? These are all points on the mean line. Because I've picked a positive value of a, I want to pick a point on the mean line that is the start of a crest. So, for example, here I'm starting a crest, but here I'm starting a trough. So I would not want to choose this one. Here I'm starting a crest, but here I'm starting a trough. So I would not pick this one. Here I'd be starting a crest. So I could use this point, or this point, and all of those would give me a correct answer. So it does not matter which one of those points I choose to use. I'm going to choose to use the origin because, well, it's the simplest one to use, but you could still get a correct answer picking the point negative 4 pi 0, or you could still get a correct answer picking the point positive 4 pi 0. It does not matter. They're all equivalent. They give you the same graph. On a test or quiz, I would give no preference. As long as your equation generated the graph in question, I would be okay with that. So, what we know now is that in our transformation, the point 0, 0 has to map to either negative 4 pi 0, 0, 0, or 4 pi 0. It doesn't matter which one of those I choose. So let's say we use this one. And remember that our general transformation that we do is bx plus h, ay plus k. And we know our values for already b, a, and k. So I can plug that all in. So I have the point 0, 0. That's on the parent function. So y equals sine x. And I have 1/2 0 plus h 3 times 0 plus 0, and that has to equal 0, 0. So that tells me then that the x-coordinate here has to equal the x-coordinate here. So 1/2 times 0 is 0, plus h has to give me 0, and then 3 times 0 plus 0 has to give me 0. So clearly 0 equals 0, so that's fine. And then if I add things to both, or if I add 0 and h, I get just h. So it tells me h is 0. So I can write my final answer now. It is 3 sine of 1 over 1/2 x minus 0 plus 0. And 1 over 1/2 is just the reciprocal of that, which is just 2. And then x minus 0 is just x, and plus 0 is that. So here is my final answer. Let's move on and look at this one. So here again, the blue graph, the dark blue graph, is the graph of sine of x, and the green graph here, or teal graph, is the function that I'm going to try to write the equation for. So just like I did before, I'm going to start by identifying or finding the mean line for my teal graph, and I see that pretty easily, it's easy to notice that the x-axis is that mean line. And from here I can find my value for a. If I look at the distance from a crest back to the mean line, or from the trough back, so the crest back to the mean line or the trough back to the mean line, I see that in each case that distance is 1. So I know the a is the absolute value of 1, and then a is plus or minus 1. Come back and make a decision about which one I want to pick here in a minute. So now that I've done that, I want to find the period for the function. So here I will start, say here. Oops. Start here at this point. And notice here, this point I've labeled for us is pi over 3, 0. If I go here, that is 1 period's length, right? And I guess I probably should have labeled this point for us. But this is the point. Well, here's pi. That looks like 1/3 of a pi. That looks like 2/3 pi. So it looks like pi and 2/3, or 5/3. Let me write that in a different color. That's hard to see. Looks like 5/3 pi. So the distance, the period, is going to be the distance between these. So it's just 5/3 pi minus 1/3 pi, which is oh my goodness, look at what I did. That's not pi and 2/3, because this is less than 1.5. That's 4/3. Ay, ay, ay. Ay, 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 I thought something was off. So when I do that, I get 3 pi over 3, or just pi. And since I know the period is 2 pi over b, I can now set up a proportion, cross-multiply, and solve for b. And if I divide both sides by pi, I got that b is equal to 2. Oh, good. I remember that the mean line is just y equals k, and since our mean line is y equals 0, we know then that k is 0. Well, that was so easy. It wasn't. It was easy, wasn't it? The last thing I need to do is I need to find h, and this is typically the trickiest part. So I'm going to erase some of this thing so we have a little bit cleaner of a looking graph to work with. So I am always going to choose 0, 0 on the parent function, and notice that 0, 0 here starts with it going to a crest, and I'm going to map it to this other point that I know on the mean line, going to a crest. Now, could you have mapped it to some other point on the mean line, like any of these? Sure, but one, I don't know the specific coordinate at any of those points where I'm given that value. And two, well, that's really the best reason, right? I'm given this value, so I want to use this one. But any of these points on the mean line would be acceptable to use. And I notice here that we have crest. We're going from crest and going to crest. So the value for A I want to pick is the positive 1. And now I can go and figure out my math. So my math from the parent function goes 2 times x plus h, and then a times y plus k, and that has to give me the point pi over 3 in the transformed one. So if I do that, 2 times 0 is 0, and 0 plus h is h, and 1 times 0 plus 0 is 0. So that tells me then h is equal to pi over 3, because the x coordinates there must be equal. And now I have everything I need to write my final answer. So y equals a times sine 1 over b x minus h plus 0. And I know that 1 times anything is just that thing. And if I wanted to, I guess I could distribute this through. And then if I add 0, nothing happens. So here is my final answer. I think I have one more example. I do. So again, the dark blue graph here is the graph of y equals sine of x. I have the same stupid typo because I'm stupid. So we're going to ignore that. And then the tan graph there is my parent function, or is my transformation that I'm going to write the equation for. So the first thing I'm going to do is try to figure out where that mean line is and draw it in. So if I think about it, I know the mean line has to be halfway in between the peak, or the crest, and the trough. So this looks like something, comma 7, and this looks like something, comma negative 1. I don't really care what the x coordinate is, I just care about these y coordinates. So the total distance between 7 and negative 1, that's 8 total units. So if I go down 4 units from the crest, or up 4 units from the trough, that's kind of where the mean line is going to go through. So I'll go from the crest down. It doesn't really matter though. So 1, 2, 3, 4 units. So this will be my mean line here. And notice that we passed through the y value 3. So this is y equals 3. And that tells me right away that my k value is 3. Now notice that we said the distance from the mean, or from that crest to the mean line is 4. Similarly, if we counted, we went 1, 2, 3, 4 from the trough to the mean line is 4. So I know that the value, or the amplitude there is 4, and I know my value for A is now going to be plus or minus. So I have my K, I have my A narrowed down to 2 values. Let's look at what my period is going to be. So, unfortunately, I don't have the full period of graph here, but if I look carefully, it looks like if I start here, I'm going to end up basically at the same spot that I started, right? So if you can't see diddly boo. Oh no, I deleted the wrong one. So I'll just do that. So if I follow along this, I notice that it is 1 period there. So I notice that we're starting here at 4 pi, or negative 4 pi, ending here at positive 4 pi. So my period, which again is 2 pi over b, is going to be negative 4 pi to positive 4 pi. That total distance then is 8 pi. And we'll do our usual cross multiplication here to solve this proportion. So I get that b is 1/4. Again, pi's cancel, and then 2 over 8 reduces to 1/4. Okay. The last piece is finding h, and at the same time as I find h, I am going to decide my value for a. So again, I'm going to start with 0, 0 as my parent function, and I'm always going to do that. You might have noticed that, hey, you've done this, picked 0, 0 as your starting point each time you've done this, and as long as I'm picking, every time I do this, I think it's the easiest point to choose. All right. So what I need to do is I need to look at the other points on the mean line for my transformation. So I have 2 choices, and it doesn't really matter which one I pick. I'm going to pick this one though. And it doesn't really matter, but this is the point. 0.5 pi, or pi over 2, and the y value is 3. So the parent function is going to eventually equal that after we do our transformation. So I do e times x plus h, and then a, let's decide now a. So notice here in my parent function at 0, 0, I start to a crest, and in my transformation I start to a trough. Since I do that, I'm going to pick the negative for A so I have negative 4 times 0 plus k, and that has to give me my transformation, or my transform point, which we said was pi over 2, 3. Again, this point here. So if I simplify things down, 1/4 times 0 is 0, and then plus h is just h. Negative 4 times 0 is 0, plus 3 is 3. And this has to equal pi over 2, 3. And since the x coordinates have to be equal, I know that h is pi over 2. So I now have everything I need to write my final answer. So I have negative 4, that's my a, sine 1 over b x minus h plus k. Oops. K, which was 3. And now I'm just going to simplify. 1 over 1/4 is the reciprocal of 1/4, so that's just 4. And if I wanted to, I can distribute this inside. And 4 times pi over 2, well, it's really the same thing as 4 over 1 times pi over 2. And just like when we multiply fractions, I can reduce, and that just becomes 2 pi. And that's as much as I can simplify. So there's my final answer. Your assignment for this is posted on Haiku. You'll be doing a similar sort of thing where I'll give you some graphs and just ask you to write the equation from it. There'll be a sheet on the same Haiku page as this video.